see that we've got the same number of particles in both beakers. But we've got different volumes of liquid, so if I have my 5 crosses in there compared to my 5 crosses in here, you can see that they're further apart. What that's representing is there's less stuff per unit volume, but there's the same amount of stuff overall. So if I wanted to compare them, I could say that, and I'll call this one beaker 1 and this one's beaker 2. Well, the moles in beaker 1 is equal to the moles in beaker 2, because there's the same amount of stuff. The quantity is the same, but the concentration is not the same. So the concentration of beaker 1 is not equal to the concentration of beaker 2, because we've got these different volumes of water. Okay, remember that concentration is equal to the moles divided by the volume. So as we increase the volume, we're going to decrease the concentration if we keep the number of moles the same. Yeah? Now, oftentimes though, we are asked to maybe calculate either a concentration or a volume after we've performed dilution. So if I started out with this volume and I added more water, what I want to be able to do is work out the new concentration. Now, we can always use this relationship. This will always work. But there is a faster way of working out this calculation. And that is if we realize that the number of moles is the same for the two of them, then we can cancel that out, if you like. We can say then, if moles is equal to the concentration times the volume, and the number of moles is the same in each, then therefore C1V1 is equal to C2V2. So we can bypass the moles altogether because they're the same in both instances. All we've done is diluted our original solution. So just say, for example, then you're trying to find out the concentration of your solution after you've diluted it, then C1V1 divided by V2 is equal to C2. All I've done there is just divide both sides by V2. And then that allows me to find the new concentration. It can work for finding the volumes as well. But the key to understanding how this works is realizing that because the number of moles hasn't changed, it's the same number of moles, we're just diluting our solution, we can just work through the concentrations and volumes. Now, if this is going to cause you some distress, then, like I said, you can just keep working through that one. It just will then require you to do 2 calculations, because you'll have to work out the number of moles, and then you'll have to work out the concentration or the volume of the in the new situation. Okay, but this is a handy one to use. It's not on the formula sheet.